Hello everyone. In these videos, we are going to learn very important topics in compilerism. Regular expression. Okay. So along with, we are also going to discuss what is regular definitions and what token representations. So don't worry if the word sounds technical. Okay. So we will understand everything slowly with the simple examples. So here, a regular expression is mainly used to describe the patterns in programming language. Like suppose if you want to if you want to came to know identifiers and numbers or keywords and operators. So these regular expressions are mainly used to describe these patterns. Okay. So in these lessons, our focus is simple: how to write patterns, how to reuse patterns using regular definitions, and how tokens are represented inside the compiler. Okay. So let's move on to these videos. Okay. Yeah, again. In this section, we will cover four main ideas. As first, we will see what is regular expressions means. Second, we will see regular definitions. Okay. So, what is regular expressions? Regular definition. Regular definitions are used to give short names to long pattern. Okay. And then third, we will understand token representation. Okay. So, what is token? A token is the output of lexical analysis. That what we have discussed in previous videos and all. And finally, we will see examples. Okay, we will not study this as a big theory topic. Okay, don't worry about that. So we will study it like it's a practical process. Input is a source code. Lexical analysis, check the patterns, and output is a tokens. This is what we are going to discuss in this video. And okay, for let us place this topic inside the compiler. So compile has many phases. First phase is lexical analyzer, right? These phases read your source programs characters by characters. It group the characters into meaningful words called token. Okay. For example, in the statements int count equal to 25 semicolons, the Lexus identifier int is a keyword, count is an identifier, equals is the assignment operator, 25 is a number, and semicolon is a punctuation. Okay. So here regular expressions helps the lexical analyzers identify those patterns correctly. Okay. Yeah. Okay. So before going to regular expressions, we need three basic words: Lexeme, patterns, and tokens. So what is Lexeme? Lexeme is the actual text, right? So written in the programs. So for example, count is a Lexeme. Okay. Pattern. So pattern is a rule used to recognize the text. Okay, pattern is a rule used to recognize a pattern. For identifier, the pattern may say it should start with the letters, then have a letters or digits. Okay, and token is a categorized name. So count became an ID tokens. Similarly, 25 became a num tokens. So these differences are very important in lexical analysis. Okay, and now let us define regular expressions in simple ways. A regular expression is a patterns. It describes what kind of strings are allowed. Okay, it describes what kind of strings are allowed. For examples, digits. Let's take digits. So digit means one digits from 0 to 9. Okay, if I write numbers equal to digit plus, okay, it means number is one or more digit. So 725 1024. Okay, so it matches the patterns. But when you take 825, so 825 does not matches because it starts with a letter, right? Similarly, when you look at this 2.5 also does not matches because it's a simple patterns, because does not have a dot. So regular expressions help us say clearly what is allowed and what is not allowed. Okay. Let's see the next slide. Okay, so these are the basic operations used in regular expressions. Okay, the vertical bar. Okay, or okay. For example, A or B means, okay, A or B means either A or B. either A or B. Okay. Concatenations. Concatenations means one symbols followed by other symbols. For example, here look at the example here. So A B means A and B. So here A is followed. Sorry. Yes, yeah, right. A followed by B. Okay, and other symbols called star. Star means zero or more times, more repetitions. Okay, plus means one or more repetitions. Question mark means optional. Okay, in compiler designs, so these symbols are used to describe the tokens. For example, if you want to write the regular expressions for digits, then we will use digit plus. Okay, similarly, if you want to write for regular expression for identifiers, then a regular expression will come like letters followed by letters or digits. Okay, suppose if you want to write a regular expression to accept the string, then our regular expression will be like from A to Z, like A or B or up to Z. Okay, let us take the most common examples. Identifiers. In programming language, an identifier means name, like total, extrudes, or mark 100. Okay, here first we will define letters. Okay, then we will define digits. After that, id means it should start with the letters. Okay, then it can have a letters or digits any number of the times. Okay, so that is why total is a valid here, and x2 is valid, and mark 100 also valid. But when you go for 2x, so 2 is invalid because it starts with the digits. In total, the dollar is invalid because dollar symbol is not allowed in the simple rules. Okay, so this rule will varies based on the programming language. When you're taking compile, so when you're taking python, the identity rule of will get varies. Similarly, when you're taking java, c, c++, any languages, so each and every programming language, they have their own rule for creating the identifiers that we have to look at. Okay, and the next one. Okay, now let us see the number. So here, an integers can be described as a digit plus. This means one or more digits. So 25 and 500 can more integers. For simple fractions, we can write digit plus dot digit plus. So this matches numbers like 3.14 and 10.5. In real programming languages, these rules can be a bigger. For example, some languages allow plus signs, means sign, exponential nationals or underscore inside numbers. But these basic ideas is same. We write the patterns and Alexas use the patterns to recognize their numbers. Okay, here a small doubt may comes here, right? The word if start with a letter, so it also matches the identifier patterns. But in a programming language, if a keyword is, if it's a keyword, so Excel should return if token, right? Not ID token. So this is where priorities become important. Usually keywords are checked before the general identifier rules. Other method is to first matches if identifiers and then check the keyword tables. The main point is this: when two patterns matches, okay, the same string, Lexers need to clear rules to decide the correct tokens. Okay, let us see the operations and the separation. Some tokens are very small, like a plus, equal, semicolons, and opening brackets. But even here we need to care. For example, one equal signs may means assignments, but two equal signs may need comparisons. When the input is double equal, the Lexer should return one EQ tokens, not two assigned tokens. Okay, this is called longest match rules. So lexicals try to take longest possible valid tokens from the inputs. And regular definitions. Okay, So regular expression is very simple. Okay, it's given name to regular expressions. For example, instead of writing all letter again and again, we define letter once. Instead of writing all digits again and again, we define once. Okay, so then we use the names inside the bigger definitions. For example, here ID use letters and digits. So this make token specifications clean and easy understands. So you can think of regular definitions like shortcut name for pattern. And these slides. So this slide shows why regular definitions are useful. On the left hand side, the expression is long and difficult to read, right? It repeats the same letters and digits pattern again and again. On the right side, the same idea is written neatly. First define letters, then define digits, then define ID using those names. So the meaning is same, but the second method is easier to understand. Okay. So in real compiler constructions, clean rules reduce mistakes and make lexical analyzers design easier. Okay. Token representations. And now we will move on to token representations. A token is a commonly represents using two parts, token names and attributes. Okay, the token names and attributes. Token names tells the categories like id, num, plus, or if. Attributes values give extra information if needed. For example, count is an identifier, but compiler also need to know which identifier it is. So attributes may point to the simple table entry. For a number like 25, the attributes values can be 25, but for plus, no extra value is needed, so it can be simply represent as a plus. Okay. Now identifiers. The attributes value is often connected to symbol table, right? So symbol table store information about names in the program. For example, if identifiers count appears many times, the Lexus can return ID, right? With a pointer to the same symbol table entry. In this slide, count point to P1. Count point to P1. So this is usually because later phases of compilers can check the type of count where it can declare and other details. So token representation is not just the names; it also help connect lexical analyzers with the later features called syntax analyzers, semantic analyzers, something like whatever the features we name from phase compilers. And here, this is the main token representations. First, we will write regular definitions for digital and letters. Then we will write token rule if represent the keywords if. Okay. ID represent identifiers, num represent number, assign represent assignment equal signs, plus represent the plus symbols. So WS represent white spaces such as blank, tab, or new lines. Usually white space is recognizes but skipped because it is not needed by parser. So for the input if x equal to 25 plus y, the Lexer produced if idx assign num 25 plus and idy. Okay, hope you understand. And let us understand the Lexer workflows. The Lexer start from current characters. It checks which token pattern can match the input. It tries to take longest valid match. If more than one pattern matches, priority rules are applied. Okay, so after deciding, it returns the tokens to the parser. Then it's moved to the next three characters by repeating the process. This is how the stream of characters become a stream of tokens. Okay, so common lexical errors. So regular expressions also help detect lexical errors. Okay? In the lexer, see characters or words that does not match any patterns. It can report an errors. For example, if the languages does not allow allowed symbols, then at symbols become an invalid characters. Okay, if identifiers cannot start with the digits, then to name is an error. Okay, if a string start with the quotes but does not have a end, does not end with the quotes, it also a lexical error. So regular expressions are usually not only for recognizing valid tokens but also for identifying the invalid input. Let us quick revise. Regular expression is a pattern for strings. Okay, it helps us identifying identifiers, numbers, keywords, operators, and separators. So regular expressions give a name to pattern, so our rules become short and readable. Token representation usually is written as a token names and attributes values. The lexical analyzers read the source programs, use the patterns, create tokens, and send them to the processor. This is the main idea of regular expressions in lexical analyzers. Okay, thank you. Thank you, everyone. I hope these explanations made this topic easy. Please revise the difference between tokens, pattern, and Lexeme. Also, practice writing single regular expressions for identifiers and numbers. So, in the next topics, we will connect regular expressions with the finite automata, understand how lexical analysis can implement it. Okay, thank you for watching.